Welcome. I'm Matt Lewis. I'm a solution architect for Amazon Web Services, and we're here for ARC402, double redundancy with Direct Connect. So we're going to talk about AWS Direct Connect primarily, and also how you can build redundancy in AWS Direct Connect. So let's get rolling here. So the agenda, we're going to start with building network foundations on AWS. So who here has built a VPC before? Pretty much everyone. Okay, good. So this is going to be, this will be probably revision for you guys. And so building a VPC is something that all of us are doing on a day-to-day basis now. So circa 2007, we had EC2 Classic. Right, so you spun up an instance, it had an elastic IP, it had a private IP, but you didn't have any way of controlling who can really access a group of instances. So you could control the individual instance with security groups, but you couldn't group instances together. So that's where VPC really comes in. And we're going to talk about the foundations on AWS. Next, we're going to talk about connecting your on-site deployment to AWS using Amazon Direct Connect. So I'll focus primarily on Direct Connect, but I'm also going to talk about VPN. VPN's a really important way to back up your Direct Connect if you've only got a single Direct Connect link. So I'll talk about that and also jump into some configurations on how you can configure VPN as a backup. After that, we'll add some redundancy. So not only will we use VPN as a redundant connection, we'll also use a redundant Direct Connect. So Amazon Direct Connect, or AWS Direct Connect, is actually one of the only physical services in AWS, so where you can actually see and touch something physical that Amazon owns. And that's the routers that you actually connect to. So you connect into a port that we own and manage. We don't give out the location of our regions, but we do give out the location of our Direct Connect POPs. So it's a physical thing. So I'm going to talk about adding redundancy into your AWS Direct Connect because everything physical can fail, obviously. And then we'll dive into a demo. So I've got a demo over here on this guy that I'm going to jump in where I've got multiple Direct Connects set up. We're going to jump in and check out the configuration, and then I'm going to fail a few links. So you'll see the redundancy kick in. So you'll see from one link to another, you'll see the traffic traverse and how to configure things like local preference and AS path prepending and that sort of thing. All right, so let's start with the foundations. So like any good skyscraper, the foundations are extremely important, and that's where you really start when you build these things. So VPC is the foundation of a lot of things that are built on AWS. And VPC is really where you can build your own private, isolated portion of the AWS cloud. So you control the networking. Think of it like an SDN. Think of it where you can automate and control the provision of subnets, the route tables, and the connectivity to your VPC. All right, so we'll start here with base VPC. So what is a VPC really? Well, it's really a nebulous thing that is a grouping of EC2 instances in a common LAN. LAN's not really the right term, but a common grouping of instances. Now, a VPC itself is really made up of just a CEDAR address range. Okay, so it's a supernet. In this case, we've got 10.100/16. So that's a supernet that we're going to allocate our subnets out of. And I saw a lot of hands before, so with people who have provisioned VPC, so I'm not going to spend too much time on this stuff. But after we've got our VPC, we take some availability zones, so fault domains within a region. So a VPC is a region-level construct, and availability zone is a fault domain within the region. And when we configure our subnets, they're going to be tied to availability zones. So think of a subnet like a fault domain as well. So if you do spin up an EC2 instance in a single subnet and you have an AZ failure that subnet resides in, the instance will also go down. So that's why when you look at the SLA for EC2, it actually asks that you provision in multiple availability zones. And within VPC, that's how you would do that with multiple subnets. Okay, so we've got our subnets. You can use NACLs to lock down the access to the subnets themselves. We then spin up some instances, A, B, C, and D. You can notice that we're in different subnets now. We've got 4/24 subnets created out of the supernet. So we've got the supernet that's 10.100/16, and we're creating the 4/24s, which is going to give us around 250 odd hosts within each one of those subnets tied to the availability zones again. Now we create a IGW. An internet gateway. You guys should all know what an IGW is. If not, it's okay. So an IGW is basically something you connect to a VPC. It's a one-to-one mapping, and that gives you access to the internet. Also, as you can see here, we can create a VGW. Now, the VGW is the important one for this discussion. The VGW is where everything from Direct Connect and VPN comes into the VPC. So it's your virtual private gateway, or your VGW. Okay, so that's where you can control your connectivity to your on-premise data center. And as you can see here, we've got a VPN connection, and we've also got a Direct Connect. Now you'll notice we don't have a VGW per VPN or per Direct Connect. It's one VGW per VPC. Now we've got two exit points to the VPC here. How do we control the connectivity from our instances? Where can instances go? How do they connect to the internet? How do they connect to our on-premise? Well, we do that via route tables. So you can see here we've got a route table within the subnet. By default, a VPC will have a route table. It's a good idea to create one route table per subnet. So you really limit that fault domain down to, if anyone changes a route within the route table, it doesn't affect all of your subnets within the VPC. So we've got a route here, or we've got a route table here assigned to our subnet, our 10.1.4/24, and we can enter a route into that routing table for our on-premise data center via the VGW. So traffic that wants to go to, say, a 172.16 will go via the VGW. Okay, so that's how you can control how your traffic's going to exit your VPC. All right, so we've talked about the foundations, VPC, and VPC really is the foundations for a lot of services. Not all services, but a lot of services that exist within the VPC itself. So when we talk about other services outside of the VPC, and one example of something that sits within a VPC is EC2. You spin up an EC2 instance within a subnet within a VPC. Other services that sit outside excuse me, of the VPC. For example, we could have SQS, SNS, SES. These Amazon simple services, or SQS, our simple queue service, for example, they're publicly addressable. So they have public addresses assigned to them. They don't sit within the VPC. Now, this is an important differentiator from other services, because when we talk about these services like Amazon S3, DynamoDB, you can't reach them directly within the VPC unless you have an IGW, or something I don't talk about here, a virtual private endpoint, which we have for S3 now. Okay. All right, so we've got our IGW. We can reach our other services. We've got an S3 bucket, that sort of thing. We've got our VPC. We've got services like Amazon EMR, RDS, our relational database service that sits within the VPC. Let's talk about connecting to those services now with Direct Connect. So that was a very quick crash course on VPC. I know it was probably a revision for a lot of you. Some might be new, so. Okay, so we've got our VPC again. I've just kind of miniaturized it there so it's still relatable. And we've got our VPC CEDAR address range, our 10.1.0.0/16. So we've got the same VPC. We've also got the VGW. So the VGW is going to be our connectivity point for DX and VPN, remember. So now we've got our AWS Direct Connect POP location. So something totally different to our AWS regions. We have 11 regions worldwide, and we have about 18, the last time I counted about a week ago, Direct Connect POPs. So they're different to our regions. We actually deploy routers in co-location facilities around the globe, and you can connect to those routers, and they are actually outside of our region. So as you can see here, we've got our VPC, but then the Direct Connect POP is actually outside of this. Now, I haven't shown any connectivity between the VGW and the Direct Connect POP. That's because that's Amazon's backbone. And we don't really talk about that too much because we manage it. It's kind of connectivity that's capacity managed and no single points of failure, and it connects the Direct Connect POPs to the local region that you're connecting to. All right, so we've got our Direct Connect POP. How do we connect to that? Well, our Direct Connect POPs in our co-location facility. In this case, we've got Equinix SV1, so in Silicon Valley, which is a very common co-location facility in the Bay Area. Now, generally speaking, and it's absolutely not required, but generally speaking, there will be a device at this co-location facility that you as a customer own and manage. Or if you use one of our AWS partners, partners like Level 3 or say XO or Zayo have devices that are deployed at these co-location facilities as well. So once we have that device there, so a customer or partner device, we build a cross-connect. So a cross-connect is basically a connection between that device and the Amazon router. So the way you build a cross-connect is you go into the Amazon console, you create a direct connect. Within about 72 hours, depending upon your account, We'll actually give you or send you a LOA CFA, a letter of authorization. So you take that slip of paper that's a letter of authorization, it has some port numbers on it, and you give that to your provider or your co-location facility provider. They then have the ability to go into our rack or into our MDF, which is a main distribution frame, and connect into our Direct Connect router. So that's what the cross connect is. It's a connection that a service provider will provision from their router to the AWS Direct Connect POP router on your behalf. Now, if you did have a point-to-point circuit from another site, you could have that provisioned all the way through as well. It would be up to the co-location facility provider to provision that connectivity as well. So we've got a cross connect there. So now we've got physical connectivity from our Direct Connect POP to the customer router that you've got at this co-location facility. In this case, we're in the colo. In a lot of cases, customers aren't actually in our co-location facilities. Hence the reason why we're deploying in more co-location facilities. When I joined Amazon, I think we had about 4 or 5 Direct Connect POPs. Now we're up to 18, so we're absolutely growing that number. Okay, so let's just say that our customer data center where our applications are is off-site. It's our on-premise deployment in a data center that's not at the co-location facility. How do we get that back to the co-location POP? Well, we probably use a service provider network like an IP MPLS or a VPLS or a point-to-point circuit or a DWDM, something similar. So you would want to contact a service provider to provision that connectivity. So once we have that connectivity, you can connect all the way through to the Direct Connect POP at layer 1, but we don't have layer 2 or layer 3 yet. So we don't have the IP addresses configured, we don't have BGP configured, and BGP or Border Gateway Protocol is the means that we're going to be exchanging routes here. And we're going to dive into BGP in a minute. Okay, so once you've got that Direct Connect connection configured, or let's say it's up and plugged in and available, within the console it will actually say it's available. Then you can go in and create a virtual interface. So we have 2 types of virtual interfaces, a public and a private. Here we're creating a private virtual interface because we want to connect to our VPC. Okay, so we configure that through the console. Then we get a configuration we can download, and we go onto the router that we've got at the co-location facility, or the partner does, for instance, and we configure the various attributes that we've given you, like BGP, the point-to-point addresses, etc., sub-interfaces. And then, actually we've got a sample here, so I've got gig 0/1, a sub-interface 807. I'm doing tagging in VLANs 807, so we're using VLANs on a Direct Connect, standard 802.1q VLANs. We've also got a router BGP 65001, so that's our BGP configuration. I'll actually walk through this a little bit more a little bit later, but this is just a sample configuration of what would be configured on that device. Okay, so we've got our physical interface, we've got our sub-interface, we've got our VLANs, and our BGP autonomous system number, and our MD5 password. Okay. All right, so once that's configured, the next thing that happens is BGP comes up. Okay, so if you're on the router, you want to make sure that you're monitoring the terminal and you actually see that SNMP trap come up, or that syslog message come up, pardon me. So BGP will come up. Then you will basically start exchanging routes with Amazon or the VPC and your router. So in this case, we've got our 172, I think, on the right-hand side here, and we'll be exchanging with the 10100. Okay, and I'll show you those routes when I jump through the actual devices themselves. All right, so now you've got your private virtual interface up. You can connect to services in Amazon S3. I'm going to take a little bit of a tangent here and just talk about public virtual interfaces. So what if you did want to connect to an S3 bucket or DynamoDB, for example? So remember, they're in the public realm. They're not within your VPC. So that's when public virtual interfaces come in. So now we've got our AWS region, we've got some services, or we've got an S3 bucket configured or a DynamoDB table configured. We want to connect to that. We configure a public virtual interface. Okay, so you do that through the console as well. Once you've created the public virtual interface, you get a configuration again in the same fashion as you did previously. You configure your customer gateway router. and then BGP comes up. Now there's a clear distinction here compared to when we had a private virtual interface, and you'll notice that we've got a public address. We've got a 203.50.24.5. Now that's a fake public address, don't try and ping that, or it might work maybe. But it is a public address because a public virtual interface is like a public internet connection without a default route. So all of the public services have public addresses, and we advertise those to you over a public virtual interface. Okay, so a clear differentiation from the private VIF. So in this case, at the customer router, you probably want to do some sort of natting, okay, because it is like an internet connection. Okay, so our public virtual interfaces come up, that's great. Now we want to talk about adding redundancy. So this is where we get into the important stuff. So as Werner Vogels says, everything fails all the time. So we want to try and build some redundant links around the single paths that we have, because if we do look at the same setup that we had just now, we've got our VPC again, we've got our VGW. Notice we've got some double connectivity here. We want to try and eliminate what are called single points of failure. So a single point of failure is a device that if that single device fails, you'll lose connectivity. So we've doubled up on our routers and our MPLS circuits into our on-premise deployment. We've got our same direct connect as we had before. So we've already pre-configured this. We've got a public virtual interface. We've got a private virtual interface. So standard connectivity that we did earlier. But you'll notice now, actually, if we just go back to this, the single points of failure here are the direct connect POP itself, so the router there, the co-location facility that we've got there, so we do have multiple co-locations you can connect through, the partner or customer router that we have there, so there's a lot of single points of failure. So we want to have a completely separate facility here where we can have another direct connect POP, another fiber, and connect redundantly to our VPC and to the public services in AWS. So again, we do need to provision our public and private virtual interfaces. BGP will come up on those again, and now we've got 4 interfaces, 2 on one router and 2 on the other. Okay, now those routes will be re-advertised back through the service provider network to your customer data center, and you can choose both paths to reach AWS. And if one fails, you can use the alternative. Now, how do we configure those alternatives? Well, we'll jump into that in just a second. Okay. So we want to configure these devices so that they act in a redundant manner. Because right now we've got similar paths with similar metrics and we don't know which way our traffic's going to go. Okay, so there's 2 different ways you can configure the links themselves in an active-passive type deployment or a active-active deployment. So we're going to talk a lot about active-passive deployments, just in the fact that we have 2 routers here, and when you do have 2 distinct separate routers, it's a lot easier to manage an active-passive deployment, so an active standby. With an active, you're basically using both direct connect links at the same time, and I'll talk a little bit about how to do that as well. So here we've got a BGP config. It looks pretty standard at the top, but the part in green, we're actually doing an AS path prepending. So I'll talk about AS path prepending in a second, but basically we're adding another autonomous system number onto the routes that we're advertising at our secondary route. And that means that that route will be less preferred than the primary. Okay, so if we just kind of take a little bit of a sidestep into AS path prepending now. So we've got our origin network, and we've prepended 3 AS paths onto our secondary path. So why would we not want to use that path? Well, we've got a metric of 4 right now. So BGP is a distance vector, it's more of a hybrid, but a distance vector routing protocol, and it looks at autonomous system hops. So an autonomous system is a network, 65501, which was our network. Then it could be 9005, which could be an AWS network, or it could be, every service provider has an autonomous system number, generally a public ASN. Now in this case, we're pretending like the path on the secondary connection is actually jumping through 3 additional service providers' networks. Now the primary only has a metric of 1 because we're only going through the 1 AS path. So we're sourcing from 65001 instead of the prepended path. So all of our traffic is actually going to come down the primary path that has 1 AS path, okay? Alrighty, so if we talk about an active-active deployment, if you do send us two routes that have the same metrics, so if you look at, it's called the BGP best path algorithm, or route selection algorithm, and that algorithm jumps through different metrics. So it's going to start with probably weight if it's a Cisco, then it will be local preference and probably AS path prepending, and MED I think's in there as well. And it's going to jump through all of these metrics to determine which route is more preferred. So we're setting the AS path prepending on an active passive. If we want an active active, what we can basically do is set a maximum paths to 4 and don't set any AS path prepending. So what's going to happen there is most of the prefixes that we're sending from both direct connects are actually going to have similar metrics. When they have similar metrics, our router on our end, our VGW, is going to do equal cost multi-path load balancing. Okay, so outbound from a VGW, it's going to choose multiple paths and spread the traffic 50-50. So what that looks like is we've got our AS path. So the route that we're advertising to the VGW, to AWS, has a single ASN because we're not doing AS per path prepending with our active-active. Then our primary or our other path also has one AS path because it's coming from the same ASN. They'd both be preferred, and we'd split the traffic 50-50. Okay, so we've now got an active-active type deployment. Now, the reason why I'm not using an active-active in this scenario is because I've got two different routers. So they're going to have different router IDs, and it's a little harder to configure an active-active on that. So I'm going to primarily talk about active-passive. Okay, so we've talked about physical redundancy. So we've had two direct connects. We've talked a little bit about BGP, and I'll dive a little bit more into BGP coming up here as well. But how could you use a VPN as a backup? So if you think about redundancy and a direct connect will cost you X amount of dollars. If you want to provision a redundant direct connect, it's going to cost you X times 2, because you basically need to buy everything twice. You need to buy 2 direct connects, you need to buy 2 routers, you probably need to buy 2 MPLS circuits, so you need to double up on everything. Now, with a VGW, now remember the VGW was our point of interconnect for a direct connect. It was also the point of interconnect for our VPN. So what you can do is use VPN as a backup. And a VPN actually costs $36.50 a month for one VPN. So considering a direct connect can cost upwards of thousands of dollars a month, depending upon the speed, 1 gig or 10 gig, or if you've got a 500 meg and you're using a partner, it can cost much more than $36.50 a month. So using a VPN as a backup is actually quite a cheap way of having a redundant path to AWS. So let's have a look at what that looks like. So I've got a double rainbow in there. I don't know if you guys have seen that before. So we've got our configuration as per before. Now, we've still got our MPLS circuits into our main data center in this case. Now, most providers can actually provision an internet trunk on an MPLS or a VPLS circuit. So you've got one physical connection there. Well, in this case, we've got 2 physical connections with multiple VLANs. One VLAN is going to be to your MPLS IPVPN or your MPLS network, and the other VLAN is going to be to the internet. So what that's going to allow you to do is connect to a VGW. So our VGW VPN endpoints are actually publicly accessible. So when you configure a VPN, you connect to a public endpoint. So from there, we would basically configure, in this case, we're configuring 2 VPN tunnels, one from each router to the VGW. So what happens is, if we lose all of the direct connect infrastructure, so we've had a double failure, you can fail back to the VPNs. And in this case, it's going to cost us $36.50 times 2, because we've got 2 VPN connections there. Now, keep in mind, just as a side point, each one of these VPN connections actually has 2 tunnels, and I'll talk about that in a second. But it's a very cost-effective way of provisioning redundancy with Direct Connect. Okay, so let's jump into some configs here, and I don't want to bore you guys too much with these. I've got a lot of slides with configurations. If you're not a BGP guy or a Cisco guy, this might put you guys to sleep, so I'll try and make it as interesting as possible. But there is something that I wanted to call out on this slide in particular. So we've got a Direct Connect interface, and I'm using sub-interface 259. I've got a .1Q259, and mind you, this is actually a live config, so I'm going to show you this exact config on a router that I've got configured here in a second. But notice we've got an IP address, sure, it's a private IP address, it's connecting to a private VIF, but we've got BFD interval 300 min-RX, etc. That doesn't look like a normal interface configuration. What I'm actually doing here is configuring bidirectional forwarding detection. So it's something I haven't talked about yet, and something I'll show you very quickly in the demo, but BFD is something we support on a Direct Connect link. And BFD is basically a mechanism for speeding up the failover of a routing protocol like BGP or OSPF. So BGP and OSPF, for example, have hello times or keep alive times and hold times. And with BGP, you can adjust those timers so that you can have, you probably don't want to go lower than maybe a 3-second keep alive and a 9-second hold time, which means it takes 9 seconds to fail over for a BGP. So if BGP goes down, so you've had a link that's gone down, BGP will go down, you'll wait the 9 seconds, then BGP will say, hey, I'm not getting any keep alive packets from my partner, from my neighbor, I'm going to fail over to another link. Or I'm going to remove that route from the RIB or the routing information base or the routing table of the router. If we have BFD, here we've got 300 and 300 multiplier 3. That's 300 milliseconds. So BFD will detect the failure in 900 milliseconds, so 3 times the 300 milliseconds interval. So you could potentially fail over in 900 milliseconds because what BFD does is it will go into the routing table and pull out the BGP route within 900 milliseconds when it's configured on the interface and also on the routing protocol. So BFD is very handy when it comes to a single router with multiple direct connects and failing between the two. You can get sub 1 second failover and also between other routers as well, and I'll show you guys how that works. But BFD is this guy here, the last line in this slide. Okay, so we've got our inter-router interface. So in this case, I'm going to show you another diagram here in a second, where we've got 2 routers connected to each other with 2 direct connects, and this is our inter-router interface. Now, the reason why I wanted to show you this was because of HSRP. So this is another important point where if you do have a router failure, so we've got 2 routers, we've got a primary and standby, and you've got a default gateway on one of those routers, a .1, or in this case it's a .254. That's what your servers are going to use as a gateway to reach the internet or reach the VPC, sorry. We're using HSRP in this case, and in fact, I think we're using HSRP sub-second hello timer. So we've got our BFD, which is sub-second, but we're also doing a sub-second failover between the 2 routers themselves. So if you do have a router failure, the secondary router will pick up that default gateway and start responding to ARPs and traffic for that default gateway. Within, in this case, we've got the 2 300s you see there, or the 300 and 900. 300's the hello time, the 900 is the hold time. So again, within 900 milliseconds, that router will pick up the default gateway and start processing packets. So very handy to do on the LAN side. So we're talking about on the south ending towards your servers now. So in this case, our 192.168.51 is actually our LAN address, not our WAN address. Now here I've set a priority. I want this router to be the primary. So the default's 100, I've gone 110. And we're preempting so that if the router comes back, I want it to remain the primary. So I always know that if that router's up, it's going to be the primary. But I thought that would be interesting to show you guys on the LAN side, because we don't often go into the LAN configuration when we talk about Direct Connect. A lot of it is just the WAN configuration. Okay, so here we've got our BGP configuration. So again, we've got our Direct Connect neighbor, pretty standard, but then here's where we add the second piece of there's 2 pieces to the BFD config. The second piece is this here, so fall over BFD. So we enable BFD for BGP. Okay, so it's very simple to configure BFD actually. It's just 2 lines of code, or Cisco config. And we've got our inter-router neighbor as well here. So you'll notice I've got 2 neighbors. One has a remote AS of 9059. That's actually our Dublin region. So every one of our regions has a different ASN number, or sorry, ASN, autonomous system number. 9059 is our Dublin region. I'm actually doing most of the testing I'm doing in Dublin. North America has its own ASN as well. I think it's 7224 by memory. Okay, and I've also got a BGP session between the 2 routers here. As you can see, the remote AS65501. So that's an iBGP, or an internal BGP session. Okay, so the secondary router, this is quite important. Now you'll notice I didn't have any route maps or any local preference or any AS path prepending configured on my primary router, because again, we're just using the standard AS path, which would be 1, and the standard local preference, which would be 100, which is the default. So here what we're actually doing, outbound towards our second direct connect, so .37, which is our other direct connect neighbor, we've got local preference in and AS path, AS prepending out. They're 2 what are called route maps. Now, the route maps themselves actually look like this. So we've got a prefix list here that is tagged on my local LAN address again, so 192.168.0.0/16. So I'm matching that address, and I'm then saying, so here in the route map, I'm matching that address, and I'm saying prepend 2 ASs onto that prefix as I advertise it out to the Direct Connect on the secondary. So my secondary prefixes here will have 2 AS paths prepended on, so they'll have a total of 3 AS paths. One that's the origin AS path, and then 2 that have been prepended. And you'll notice here the inbound route map we had configured. If I just jump back here for a second, try not to jump around too much. Notice how we've got local preference in there, it's that guy there. Inbound, we're going to set a metric as well. So that's this guy down here, down the bottom, so set local preference 90. So lower is worse, it's a worse metric, 100 is the default. If you go higher, it's more preferred. Setting a local pref of 90 will actually mean that local preference is less preferred. So again, our secondary route. Now the reason why we have AS path prepending and local preference, AS path prepending is going to be for the routes advertised to Amazon. Local preference are going to be the routes advertised from Amazon. So AS path prepending is going to be Amazon sending traffic to you. Local preference is going to be you sending traffic to Amazon. Okay, so you need to do the metric configuration in both directions for both directions of traffic. All right, so I did say we're going to add VPN in here, so we're going to talk about some VPN configurations. Now I have got some pretty straightforward VPN, and I can show you an actual live VPN config, but I just wanted to point out here, for the VPN itself, we've got, again, some interfaces. So I've got a tunnel 1, and again, with any VPN in Amazon, you do need to configure 2 tunnels. The reason being, each tunnel for a VPN connection connects to an appliance on our end, a hardware device, or a device that could go down. So it's a good idea to configure both tunnels, because if you only configured one and that device went down, you'd lose your VPN. So and it doesn't cost you anything extra to have 2 tunnels. All right, so we've got our 2 tunnel interfaces. Now we've got our standard BGP configuration. And you'll notice here, we've also got a local pref VPN in and an AS path prepend VPN out. So I've created 2 new route maps. I could have probably matched on IP addresses, or I could have probably made things a little bit more streamlined, but I've chosen to have 2 different route maps here. So if we look at those route maps, we've got our AS prepend VPN, and I'm adding an additional AS autonomous system number on this guy. So remember, our secondary had 2, so a total of 3. This guy has 3 getting added to a total of 4, so he's even less preferred than the secondary BGP link. So the failover should start on the primary, and the primary will always be preferred because of the 1 AS. If that fails, it should go to the secondary, which has 2 AS paths. If that fails, it'll go to the VPN, which has 3 AS paths. And also, again, we do need to set both directions for traffic. So we've got a local preference of 80, which is 1 or 10 lower than our 90, which was the secondary, and 10 lower than the default, which was our primary. All right, so this is kind of what the architecture looks like. So I've basically got a test node, a 192.168.51.10 on the right-hand side, which is a host in our lab in Dublin. I've got 2 routers there, router 1 and router 2, and then I've got some VPN connections that connect over to a VGW. Now, each router also has a single direct connect. So the single direct connects, in this case, I don't have any public virtual interfaces. And actually, one of the sessions I might send you guys to after this tomorrow, Steve Seymour, one of my other colleagues, is actually going to be talking a lot more about public virtual interfaces. So that might be worth checking out. But in this case, we've just got 2 private virtual interfaces, and we're connecting to a VGW. And inside the VGW, I've got a test node, a 172.16.0.15/24. So that's inside my VPC. So the idea here is we have connectivity between the 2 nodes. We can ping, we can transfer files, we can do everything we want to, and then we start failing the links and watch the redundancy itself. So let's jump into the demo now and have a look. So I'll just bring that diagram back up. I'm just going to, just for 2 seconds while you guys digest that as well, I'll connect to my, I'm actually using a workspace here, so. Has anyone used Amazon Workspaces? A couple of people? Okay. It's actually pretty awesome. So the workspace I'm using, and I'll show you guys that in a second once I've got all my connectivity up and running here. The workspace I'm using is actually a corporate workspace. So whilst I normally need to VPN from my Mac natively into, let me just connect to some routers here. I normally need to natively VPN in. If I use a corporate workspace, it's actually already sitting within the Amazon container, and I'll show you how that works. It's pretty awesome. And there's another session which I might send you guys to from another colleague of mine, Steve Mueller. And he actually talks about how we build workspaces and build them within a corporate environment, it's pretty awesome stuff. Sorry guys, I know I don't have anything up on the screen here right now. I'm just still connecting to my hosts. Almost there. I've got 4 that I'm connecting to. Okay, and I need to remember a password here. Alrighty. Oops. Sorry, this must be pretty riveting for you guys. Okay, so I am connected. I've got that guy. Thank you for bearing with me here. Okay. Alrighty, I hope this works for you. Okay, so I've got a whole heap of terminals here that I was just booting up. So I'm going to make this a little bit bigger as well, because I know if you're like me and need glasses, it can get pretty hard to see. I'm going to primarily be showing you guys the configuration here on router 2. So if I just zoom in here a little bit, can you guys all see that? Like if I do a show, let's do a show version. Does that look okay? Yeah? How about up the back? Yeah? Cool. All right. Okay, so what I've basically got here is we've got 4 terminals. So the yellow one that you see here that I'm on is actually router 2 that I've got configured. This green one over here, if I do a show version, this guy's router 1. So in that topology, I've got router 2 and router 1, and then I've got 2 hosts. So remember I had our host here, if I just do an fconfig, this guy's actually 192.168.51.10. And then if I just jump on this guy, you can see by the prompt there over here. Can you guys see my mouse? Oh, good. You can see that guy's a 172. So I've got my 2 hosts. So just to jog your memories there, we've got the host on the right-hand side, the host on the left-hand side, and I'm also connected to the 2 routers there. Alrighty. So let's have a look at the direct connect on this guy. So we're going to do a show IP. We'll actually just do a show IP interface brief. Oops. It's always weird standing up and typing away on a laptop. Okay, so I've got a couple of interfaces here that you can see. I've got a 51, which is actually my LAN interface. So remember the HSRP interface that we're talking about. And I've also got a 000.260. So that's my sub interface for my direct connect. So if I do it, let's concentrate on that. Let's start with the direct connect first. So I do a show run interface GI 0/0/0.260. Okay, you can see it's a pretty standard configuration, and oh look, we've got our BFD guy configured there as well. Okay, so we do have BGP configured on this as well, so if I do show run pipe to begin router BGP, so I'm just showing the config component of this that shows the BGP configuration. Now on this as well, I've also got some tunnel interfaces. Now, I did want to fail from a primary to a secondary to a VPN, but unfortunately the lab doesn't have unblocked internet access, so I tried to get that fixed, but they wouldn't allow it for me, so maybe next time. But I do actually have a couple of other BGP neighbors here, but the one we're interested in is this guy here. So it's starting on from this line, because I know it gets hard to see because of my highlighting there, but this guy here, the 37 is actually our first direct connect, it's our secondary. So you'll notice I've got route map local pref in, route map AS prepend out. Let's have a look at the routes that we're actually advertising. So if I do a show IP BGP summary, You can see I've got the 4 sessions there, so I've got 2 from my VPNs there, shut down, but my two BGPs here, the 37 is my direct connect, the 254 is actually my inter-router connectivity. So I've got to have an iBGP session there. But if we then do a show IP BGP neighbor, and I'll take this guy here, you can see that our remote AS is 9095. It's been established for an hour and a half. I was playing around in the lab earlier. If we now do a received routes, oops, you can see that we're actually receiving our VPC CEDAR address range, so our 172.16.0.0, okay, via that link. So if I do a show IP BGP on that prefix, you can see that we've got a couple of paths here. So one is, what have we got? One here is via the 169.37. So remember, this was this direct connect on the secondary. The local preference is actually 90. Now, we've got another path here via this 254. That's via the inter-router link. So traffic would actually hit this router, jump across the link, and head out the primary DX because we've got a local preference of 100 there. Okay? Now, if I just have a look at the route map configuration, you can see that we've got, same as we had before, I've actually got the 2 route maps configured. I've got the VPN route map where I'm, or local preference, where are we here? Local preference setting to 90 and our AS prepend on 655 times 2. Our VPN again looks the same as what it did in the slide deck. We've got 3 AS paths being prepended on there and a local pref of 80. All right, so if we've got our primary, we're going to show IP BGP summary. Let's have a look at router 1. So we've got, this is our primary DX link. So we'll have a look at that neighbor. This is all pretty standard stuff. So again, we're receiving and sending some prefixes. So let's have a look at the received routes on our primary. Okay, we're receiving the VPC address range. And if we have a look at advertised routes, we're advertising our local LAN address, the 51, okay? So we should have 2-way connectivity. So I'm on my host here, which is actually the 192.168. I've got my EC2 instance spun up inside my VPC, which is a 172.16. If I do a TCP dump here, and then I ping 172.16.0.15, you can see we've got connectivity, okay? Now, what I'm actually going to do, so because of our metrics, if I do a show run pipe to begin, oops. If we have a look at the metrics that we have configured, notice that I've got some stuff here. I was going to set the local pref to 150, but I didn't, so there's some config that I should probably clean up. But I'm not actually setting on that BGP neighbor, I'm not setting anything. So it's got the default AS path and it's got the default local preference. So we should be preferring this link right now. So what we're going to do is do a show IP, show IP interface brief. This is our direct connect link here. Let's grab that guy. Oops, my mouse isn't working. Hey, go away. Okay, there we go. Now we do a conf term. So I'm jumping into configuration mode here of the router. I'm going to go into interface configuration mode for that, and I'm going to shut down that link. Oh, actually, one important thing. I want to do terminal monitoring first. Because I'm actually SSH'd into this router, I don't see all of the syslogs that are going to pop up. So I want to do terminal monitoring. So I've just done do terminal monitoring, and here I'll go terminal monitoring as well so we can see any errors that come up. Okay, so now let's shut down that link. So I've just shut down the primary link. You can see we had a BGP interface flap. Things have shut down. Let's see if we lose any packets here. I don't think we even saw anything happen. Okay, so, well, we've got 2 direct connects, so let's prove that everything is going to fail if we see these guys both go down. Let's do a show IP interface brief on this guy. Here's our direct connect on this side. And let's just do a conf term again. Jump into the interface here, and we'll shut down our second direct connect. Okay, so that BGP neighbor's gone down now as well. and we've lost connectivity. Okay? So we've effectively isolated our network. Now, what I wanted to do was use tunnel 1 and tunnel 2, but unfortunately, because the VPN connections were being blocked on the internet here, our corporate security guys weren't too happy about me VPNing out through the lab. I can't actually bring those guys up. Well, I can, but you actually see a asymmetric routing, so we'll keep those guys shut down. But let's do this now. Let's unshut this, or no shut, and let's see how long it takes BGP to come back. Okay, so it's pretty quick, right? Now we should actually see it fail back over to this guy if I do a no shut, and I'll show you guys with an MTR in a second. It should actually fail from this guy to this guy because when this BGP comes up because of the local preference and the AS path, okay? So let's do this. Let's cancel this guy, and let's cancel that guy. And now, let's do an MTR. If you guys are familiar with my traceroute, very, very handy tool. Let's do a 192.168, oops, 192.168.51.10. Oh, whoops, I need a sudo here, don't I? Yeah. 192.168, you guys are paying attention, good. Okay, so we're now doing an MTR. So you can see the path that we're actually taking to reach that host. We're going via .2. Now, if you remember, excuse me, if we remember who .2 was, oops. This guy here, the sub-interface is actually .2. Okay, so we're taking that primary path. Let's shut down this guy again whilst our MTR is running and see what happens. It gets a little bit flaky because MTR still thinks there's a host in the path and it tries to time it out. So we should see an additional path get injected in there, which is actually the other path because the packet is going via the primary. MTR knows that path, it builds that path, and then it fails to the secondary and it injects another path. But let's see what happens. Let me just make sure I'm in the right interface here. I don't want to do anything too crazy. Okay, and now let's shut that interface and see what happens on the MTR. Let's make that a little bit bigger, actually. And we'll put it down here. I'll make this guy a little bit smaller. Okay, so we're on that interface and we shut that guy down. We should see BGP go down. Ah, see, we failed over to our other path. See, now suddenly we've got this 38 that's appeared from nowhere because it's an additional path in there. Now, that's because MTR is trying to time out the .2. It just suddenly sees a different path. So let's Control C that and do it again, and you should see it by the 38, right? So that was from before, I think. If I do a do show IP int brief, you'll notice here on our Direct Connect, the 38 is our interface address. So the MTR, you saw how quickly the BGP actually failed from the primary to the secondary, and that's really BFD in action. So let's do it again. So we're on the 38 now. Let's see what happens if we bring up this, this primary. So let's do a no shut on this guy. I think it will actually take a little bit longer. There we go. Okay, so it's up and it's failed over to the other one because we saw the additional path get injected in there. Now if we just did a Control C again and an MTR, you can see it's now on the primary. So the failover itself is actually pretty darn quick when we're talking about BFD. Let's just shut that interface again. You can see it fails over almost immediately over to the secondary DX link. Okay, so if I then went back here and I did a ping 172.16.0.15. Now we're pinging again. Now if I do a no shut, we don't really see much happen in the way of pings because the ping is every second, right? And remember our BFD timers, they were 900 milliseconds in total, which is less than a second. So we might see a couple of packets drop here, and sometimes I have seen BGP play a little bit not nicely, but overall the failover is pretty damn quick. So I think that kind of shows you guys, you know, configuring BGP. We've really gone through BFD configurations. We've gone through a multi-DX setup, so how you can have multiple routers with multiple DXs, and real-life configs as well. So you saw what was actually in the presentation was what you saw on this router itself. So if I just jump back here, So you can see this implementation is really, you can configure double redundancy by having 2 direct connects and then using your VPN as well on the side of that. But you do need to keep in mind your metrics and set your metrics for each one of your BGP sessions. Okay, so in summary, we really started with building our foundations on AWS. So we started with VPC, we started with services that sit outside of a VPC as well. Then we jumped into connecting our on-site deployment. So we talked about Direct Connect, we talked about the components that make up a Direct Connect. From there, we added some redundancy. So remember, redundancy is very important when it comes to Direct Connect. A single link can go down. And I think I told this story yesterday in one of my sessions as well. I was doing a build out in a data center, and we weren't allowed to lift the floor in the data center itself because of the fire suppression systems. So to run some fibers, we actually got an umbrella. We tied the fiber on the end of the umbrella, and I passed it through, and then my buddy went to the other end and pulled the umbrella through the flooring. Now, when we pulled the umbrella, totally silly, but we pulled the umbrella through the floor, we actually pulled out about 6 fibers. And unfortunately, it was a large mobile provider in Australia, and we took down about 40,000 users. So it was at about 3 a.m. in the morning, so we plugged everything back in and everything was good to go. But I have seen firsthand how fibers can get pulled, how fibers can get damaged, how things can go down. And when we talk about Direct Connect, it is a physical fiber with a physical router. Our routers have redundant route processors and redundant power supplies and that sort of thing, but things do happen, and people do sometimes use umbrellas to run fibers. Not in our data centers. They don't let me touch anything like that anymore. Okay, so we did also jump into a demo. So you saw the live configurations on BGP and how it actually works, and you saw how fast BFD fails over. Okay, so 2 sessions I think are worthwhile checking out. So one is Steve Seymour's Net 406. It's a deep dive on AWS Direct Connect. It'll be a lot of repetition on what I've actually talked about because it's the same service, but I think we tried to split the focus out. So he's going to focus a little bit more on public virtual interfaces, and I was focusing a little bit more on private virtual interfaces. And also, oh, I didn't show you guys the workspaces. Let me just jump in there. I got a little bit distracted with my BGP config. So I do actually have a workspace over here where if I log into this guy, I actually have the AWS console spun up. So if we did want to jump in here just really quickly, because we're almost out of time, jump in and have a look at our VPC configuration, which was, you know, pretty straightforward. I just had 2 VPCs there. I had a VPC, I had an instance spun up in that. But more importantly, if I have a look at my Direct Connect configuration, just to see what that looks like. I've actually got 2 interfaces. Remember, I shut one here, so one's down, and here's the other one. So you can see that VLAN 259, 65501 ASN, our peer IP addresses. So that's there configured under the console. But yeah, so pretty straightforward as far as DX goes. However, if I jump back here, yeah, the second session, how Amazon.com is moving to Amazon workspaces, probably worthwhile checking out. There's a large focus on subnetting and how do you build things like 4,000 workspaces instances in a VPC. So I really like that session just from the fact, and I worked a little bit with Steve on the content, just from the fact that building a large-scale system in AWS in a VPC, I mean, I was more about the connectivity to the VPC, but this is more, how do you do subnetting and CEDAR addresses and when you need to have 4,000 and 8,000 and 12,000 users and that sort of thing. So probably a session that might be worthwhile attending. Okay, thanks guys. One last thing, don't forget to fill out your evaluations. Thank you, thanks for coming.